Thank you. Thank you. I'm quite new to the AI industry, but instead I will talk about one of my favorite subjects, requirements and processes, and compare to what I have done previously. I will go into this a little bit, but first I will tell you a little bit about Annotell, if you don't know what we are doing. Annotell was founded in 2018 by our CEO, Daniel Lankilde, and Oskar Pettersson, COO today. And today we are 70 plus. I actually heard the other week that we might have reached over 80 people recently, and we are a mix of people from different areas in the industry here. You can see, yeah, I represent a few of them actually myself. We have an office in Sweden, here in Lindholmen, and in a small one in Munich, in Germany also. We have basically three main products. We have a ground truth production, labeling your data, which is our biggest one. We also have data quality analytics to understand what kind of quality do you have on your label, so you can actually achieve what kind of quality you have in your AI model, and then believe what the AI model is telling you. And the third product is the safety and performance measurement of the perception system. We mainly work with, or we only work within automotive, and the perception system is the part that collects the information about your environment, cars around you, roads, weather, yeah, and also ego vehicle and stuff like that. So the third here is to analyze what kind of performance you have on your metrics using our ground truth, of course, and also what is needed to state that you have a safe perception system. And just a little bit about me before I go into my subject here. I have been working within ADAS and AD for 14 years. I have been working both at the OEMs, Volvo cars, CEVT and others, but also at the supplier side. I have been working with the sensor algorithm development, as well as the customer end function, like your ACC function, AEB function you have in your cars today. But I have only been in the AI industry here for 6 months when I started at Annotell. So this is a new learning for me, and that is very exciting for me. Currently, I'm the team lead of a small department at Annotell we call Perception Research, and where we try to figure this kind of, what is a safe perception system? We try to figure this kind of questions out. But I also work as a perception expert, where we advise our customers how to achieve the quality and what you need in your labeling. And then I will go into my subject here. So I will start with some labeling examples here from automotive industry, typical examples of what we can get. For instance, label all pedestrians could be one, but should we label them separately, like in the blue boxes here, or is it good enough with the red boxes here? Both could probably work for your training model, but if one annotator does it in one way and the other annotator does it the other way, the AI model will probably be confused in the end. So it's need to be specified. Should we include like a backpack, or if you have a trolley behind you or in front of you, or umbrellas? Should that be included in the annotations? And also, like here in this example, should we include cargo on a truck like this? So all of these needs to be clearly specified to not be ambiguous and be a little bit random and mixed when you get your data, which you should use for training your model in the end. So I will start by putting a little bit of a simple lifecycle of an ML project, as I have understood it. So first you define the scope of your project, what you want to achieve. You collect some data and you label your data to achieve the goal of your model. Or you train your model, and this is an iterative approach here, so you could label more, or you could tune your model, but typically it's more effective to actually enhance your data compared to trying to make your model better. And then you deploy your model or your product into production. And then if we make the similar life cycle of a more traditional software project where I have my background, you define your project, you make your system design, specify, put requirements, and quite normally, quite detailed, write down what you want your system to perform. You hand it over to a developer who implements your system, your requirements. You start to verify your requirements and do testing. And here, this iterative loop might start. You could reiterate the implementation or even the requirements if they were wrong. Never happened in my case, of course. And then you deploy your system into production. And these two are quite similar here. So if I compare them on the same slide here, define your system, collect and label your data would actually mimic what is the design and writing the requirement of your system. And then implement and verification, that is where the AI comes in and reduces the workload. And then we deploy our system into some kind of production. But in our experience, the same effort in describing what you want, what kind of data you want, and how do you want your labels in my previous examples, typically the same effort is not put into this description compared to what you do in a traditional software where you have a review process for your requirements and so forth. You have a tracking system, you connect them and trace them in different test cases and so forth. So that is what I would like to compare a little bit. For the requirement management process, there are quite rigorous help out there. A requirement how to write the requirement, for instance. It should be necessary, it should be specific, it should be understandable, accurate, of course, it should be feasible, it has to be possible to implement, and it should be testable. There are kind of these keywords you should think about when you write your requirements. But we do not apply the same methodology when we write instructions for an annotator or similar. So why not use the same kind of wording for an instruction? It should still be necessary. It should be specific. It shouldn't be too general because then like annotate all pedestrians. Because it should be understandable. And here it's even more tricky than compared to an requirement because it should be understood by typically hundreds of annotators because many cases this is a manual process. And of course accurate, it should be comprehensive. It needs to include descriptions of all possible scenarios. And again, it should be feasible. We can get requirements of, we want the bounding box on a point cloud to be on 1 centimeter, but if you go up to a car, could you even tell by 1 centimeter where the corner or the boundary of the car are, since it's so rounded and there are different stuff pointing out everywhere. And here is the important part. It should be measurable. We need to be able to measure this instruction actually. And this is where I want to continue to how do we actually achieve this unambiguous labeling instruction. We should use the same principles as we do for requirement. We should divide our instructions. Typically, we get a long document with a lot of pictures, but we cannot trace an individual instruction and analyze it, test it, and put measurements to it, basically. So we should divide our labeling instruction into single instructions so we can trace them, put a number on them, and version control will be easier then. We know if we change one instruction, we know what instruction, instead of changing a complete document and don't know exactly what has been changed in the document. We should, if we have this kind of, we can test each instruction actually. And see that it actually works out for the annotators, that they understand it and that we achieve what we want. And then we came into the quality of the analytics. And here are some examples how we can achieve this. Typically, when we do this, we let 5 to 10 annotators annotate the same instruction. And in this, and then we build metrics on how they agree on how to label stuff. And here is one example where with this picture here, where it's a semantic segmentation here. So the road should be with the polygon here. This is road, this is a wall, a sidewalk, and so on. So if we do this kind of pixel-wise class agreement here, for instance, how do the annotator actually agrees on the class, on the different parts here? You can see here this line on the side here. That is where the road ends and the sidewalk starts. And of course, it will not be exact same pixel from different annotators where they judge where the sidewalk starts compared to the road. But we can also see here on the left side here there are some class confusion actually, if it's a sidewalk or if it's a road, or I'm not sure exactly what kind of classes we were annotating in this different. But you can see that there are areas where it's not obvious what they should annotate. Here is another way to measure how many unique classes we have in the different areas. Also here we can see that there are 2 classes that they actually that are unambiguous or that we select from. And also a little bit, before I summarize here, I want to emphasize how your label quality actually affect your machine learning model here. Typically, if you have random, uniformly distributed annotation errors, your machine learning model will probably some kind of making an average of it and learn the middle way and the correct way, hopefully. But we actually don't know if annotation mistakes are random. Like in my first example here, if some annotators make a big bounding box and some makes a small bounding box, that cannot be treated as a random error. And if we actually are making wrong stuff in our guideline, it will be a systematic error. And that, of course, it will not learn. Then it will learn wrong, and you will get your wrong function out of it. And this is typically caused by ambiguity in the labeling guideline. Systematic errors, as I said, that will actually cause a bias. And that will affect both your training and your validation. I just want to mention also about random mistakes. That might be okay when you train your model, but later on when you're measuring your model and you want to understand what kind of confidence you have achieved or what kind of metric, whatever kind of metrics you are using, loss ranking if you have random mistakes in your annotations there, they will affect your measurement and the understanding of what your model are performing when you are doing the validation part of your model. So here I would argue that not even random mistakes are okay. And you actually need to know what kind of quality do you have in your data set. Otherwise, you cannot separate your model performance from your ground truth performance. Yeah, and typically systematic labeling errors, that is caused by mistakes in the labeling guideline, as I said. If you miss something, you don't have enough examples. Edge cases, we want a lot of edge cases. How should we annotate if a pedestrian is carrying another pedestrian? Should it be one or should it be two? Yeah. There is a lot of edge cases you need to think about and how you want your machine model to actually act in these situations. And then, as a summary, what I want to bring out from here is that the labeling guideline should be seen as the requirement specification of your machine learning model. It is not just something you send out, but you should really put effort into this, review it and try to trace it and so on. I recommend to put as much attention as we normally do in a traditional software project to the labeling guideline as we do for the requirement specification, because identifying an error in a specification is much cheaper than identifying it when you have put it into production, or even if in the testing phase of your situation you need to retrain or you need to collect new data. If you find a mistake in your data, you retrain it. That will typically be very expensive. And it will also be better from quality assurance point of view if you actually have this kind of normal process for your labeling instruction. I also recommend to use specific tools to identify your instructions, version control them, and trace your labeling instructions to a test cases like I showed before. Yeah, exactly. Your labeling guidelines should be tested and measured before you start your data product, because data production, because it will be expensive to redo it or retrain your annotation workforce. That was everything for me. Here is my email address if you want to reach out in anything or.
Thank you, Tommy, for this very interesting talk. And I guess it's not so the sexy part of this area, but very, very important.
It is.
And
it
so,
is.
so how
and we see in a lot of our customers that they neglect this area actually.
Yeah, well, think about that with the requirement process in normal software development.
Yeah.
We usually skip that as time as well. So, but are there any questions? Yeah, great.
Thank you so much.
Thank you.
I wanted to ask, you talk about ambiguity in the guidelines, should be avoided at all costs, but what about ambiguity in the data itself? I mean, you talk about edge cases. How can you possibly cover all the edge cases? And the annotators will quickly become more experienced in the data than the person who wrote the guidelines. Yeah. And they will see much more. They could sometimes be all right. So either your guidelines are like 100 pages long, and is that good? Like, can annotators, humans, actually deal with that level of precision?
It's a very good question, and I think it's two questions actually, because you are completely right. The annotations will never be 100%. They will not be correct. There will be errors or mistakes in it, but what we need to be certain about is how much errors. How do we understand what kind of quality do we have, so we can understand what is the quality of our machine model, because they will influence each other, of course. And the second part is how to find all the edge cases and a long instruction. And I think that is one of the purpose actually of dividing up your instructions in parts, because then it will, if you have some kind of database tool, then the annotator actually search, or we can actually automatically give the annotator examples where he is and are working, so to say. This is how it should look, or this is example of these situations and so on. So I think it's a big document of 100 pages will not be good, of course, but that's why we need to separate it in smaller parts so we can find whatever kind of situation the annotator are working on.
Thank you.
And regarding your edge case question there, I think it's an iterative process. We should add the, but it doesn't make sense if it's very rare cases. Then it doesn't make sense to add it to the guideline, because then it will happen only once and it will not happen again. But we should have an iterative approach to actually identify them and annotate them correctly what you want.
Okay, so I have a question regarding like what difference the improved annotation actually makes in the end. Do you have some measurements of like what kind of improvement you get as you label more consistently? Have you made those kind of tests?
Yeah, we are doing those kind of tests, but I actually read a presentation from Andrew Ng, like he mentioned in the keynote session this morning, and he compared actually what are the improvements you can reach by improving your data and making it less noisy compared to improving your model. And the result he got, I think it was from an identify material, some kind of material in metal. They wanted to identify unclean parts of the metal or something. And I think he came to the conclusion that if you clean your data, you will have the half amount of data need, so to say. So a good quality of data might, it will reduce the need of your data set, basically. And there were no numbers on how good it has to be, so to say, but it is as effective, or at least more effective, to actually clean your data compared to tune your model or add more layers into your model and so forth.
Thank you. I think those numbers would be really interesting to see.
Absolutely,
and
I
see
totally
if it's
agree.
5%, 10%, or what kind of numbers we're talking about.
But I can recommend. Andrew has done some presentation in this topic actually. I think I found it on YouTube.
Yeah, but I'm thinking as a company here that works with many different data sets, you would have the luxury to actually see in practice, not as a theoretical thing in one study.
Absolutely.
So it would be really nice to see.
I will bring that with me. Thank you.
All right, great. Two great questions and answers. So do we have any more?
I cannot see.
We have one here.
Thank you. It's a very interesting topic and the presentation. I'm very curious about one thing is about, I agree with that the label quality is quite important for the, as well as data quality for the machine learning projects. And do you have any ideas about how to measure this label quality? And it's true that the human annotation could make errors during this process. And there's common ways through like the error analysis to this kind of iteration, but is there any good suggestion on how to measure it?
We have two ways at Annotell. Either we let annotators, multiple annotators, annotate the same thing, and then we can measure the disagreement, or we can merge it, we can compare, we can make average numbers and so forth. Or we also have a set of expert annotators that are proven to do this very accurately. And then we send a part of the data to this. So you have the big workforce, and then we send a part of it, random sampled parts of it, to these expert annotators, and then they do some corrections where it is misleading. And based on these corrections, then we calculate what are the quality on the complete data set, because we can, since we are selecting it randomly, we can assume that all the data set contains the same kind of issues that these expert annotators are finding.
Thank you. And I have another question.
Yeah.
Yes, it's one point about the label versioning, and it made me think about the. Today we're talking about the data drift and the concept drift, but how is it in the reality that if the label labeling the guidelines for the label versions like changes quite frequently, so it can be considered as a labeling drift?
Yeah, absolutely, and it's important to keep also the data set. Then, of course, to understand this data set is handled with this version of the labeling guideline, right? Because it might be different, or if you want to redo your data set. So I agree with you. The drift is important to keep in control. But it's more important to understand what kind of labeling have we done for each of your data sets, so to say, so you understand what are in there.
Yeah, that's very
was
nice.
that answer to your question?
Yeah. That's very clear. Thank you.
Thank you.
Thank you, Tommy,
for
a great talk and great questions.
Tack.
Snyggt.